We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello all, this is Amit KULKARNI, Assistant Professor in SHRI and RC College, UMRAKH, BARDOLI. So, in the previous lecture, we have already studied Thevenin's theorem. Today we will be studying with Norton's theorem. So, Norton's theorem is not that much different if you know Thevenin's theorem, because you will be studying here that instead of VTH you need to find IN, that is Norton's current, and instead of connecting equivalent resistance in series with the voltage, Thevenin's voltage, you can here replace the equivalent resistance in parallel with the Norton's current. You can say that source transformation of Thevenin's voltage and Thevenin's resistance is Norton's current in parallel with the equivalent Norton's resistance. So let us see what is Norton's theorem. So Norton's theorem states that a linear 2-element circuit can be replaced by an equivalent circuit that consists of a current source IN in parallel with a resistor RN. Okay, so it states that for a given linear circuit, this whole linear circuit can be replaced by one current source, that is IN, and that can be replaced with one Norton's current source and one Norton's resistance Rn, where this IN is the short circuit current through the terminals and Rn is the input or equivalent resistance at the terminals when independent sources are turned off. Okay, so again the same circuit, if you remember Thevenin circuit, the load resistance was there. Okay, so in the load resistance, what we were doing, we were open circuiting the load resistance and finding the open circuit voltage. So we were removing this resistance and finding the open circuit voltage. We were finding VOC. So over here, what you need to do, instead of open circuiting, short circuit the load resistance and find the current flowing through that through that load resistance, and that current which is flowing through this load resistance when this is short circuited is said as IN, that is Norton's current. And to find Rn, it is the same method that is found in the RTH also. You have to remove all the independent sources present in the circuit. When I say all independent sources, it means independent voltage sources must be short circuited, and similarly independent current sources must be open circuited. So let us see the steps to solve Norton's theorem. The steps will be: first, to short circuit the load in the given circuit whose unknown parameter is to be calculated. Then find the Norton's current that flows in the load branch, and find the Thevenin's resistance RTH by short circuiting all the independent voltage sources, and or you can say open circuiting all the current source which are present in the circuit, and find the equivalent resistance looking into the circuit from the load side, and finally make an equivalent Norton's circuit. So equivalent Norton circuit will be arranging Norton's current source in parallel with the Norton's resistance, and that will be in parallel with the load which is to be now connected in the circuit. So let us understand Norton's theorem with a simple example. So over here you can see you have to find the current flowing through this 4 ohm resistor, that is this resistance, and you have to solve this using Norton's theorem. So Norton's theorem, it is simple. You just need to short circuit this and find the current, Norton's current that will be flowing over here, and then open circuit this term, this 4 ohms, and find the equivalent resistance in this circuit, and then keep Norton's current value and resistance, equivalent resistance value in parallel, and then in that parallel to those two you have to bring this 4 ohms. So let us understand this. So the solution will be in this way. First you need to short circuit the Norton's current. Okay, then after, so this is your first step. Second step, what I have done is that you need to find Norton's current. So how you need to find Norton's current? So you need to solve this circuit. So over here you can see this voltage source is in series with this resistance. So this voltage source in series with resistance can be shortened. Okay, you can do a source transformation. So 3 by 2, that will come in parallel with 2 ohms. It is nothing but V by R. So I is equal to V by R will give you 3 by 2. So this will become 3 by 2 amperes current source, and that will be in parallel with 2 ohms. And over here if you see this 5 voltage in series with 4 ohms. So this also comes in, becomes a current source if you do source transformation. So it will be 5 by 4 and here 4 ohms. And over here and last I have taken this 4 ohms that was short circuited and this 5 volts. So here I have written 5 volts. So this 3 by 2 and this 5 by 4 both are in upwards direction. Okay, both are upward direction, it means same polarities, so you can add them. So 3 by 2 plus 5 by 4 will give you 11 by 3. Okay, so that 11 by 3 will come over here in, so I think over here it should be over here. So okay, so this is first and this will be second over here, and then you will go over here. So in this step you can see 11 by 4 will be the equivalent of 3 by 2 and 5 by 4, and in parallel to that this 2 ohms and 4 ohms, their equivalent will be 8 by 6. So you will get this, and in parallel to that there will be a Norton's current and 5 volt voltage source that was given here. So after that you have to come over here. So over here you can see 11 by 4 and this 8 by 6. If you see this is current source in parallel with the resistance, you can do source transformation and you will get 11 by 3 in series with 8 by 6. And over here you already have this Norton's current. So now you can find the Norton's current simply by a KVL loop. Okay, simply by a KVL loop. So you will come over here. So it will be 11 by 3 minus 8 by 6 into IN, and plus 5 volts will be equals to 0. So from this you will be solving this and you will get Norton's current to be 6.5 ampere. Okay. Now you already know. So this is your whole second step. Now third step is you need to find Norton's resistance or Thevenin's resistance. So to find Thevenin's resistance, what you need to do, you need to remove all the independent sources which are present in the circuit. So over here this 3 volt, this 5 volt and this 5 volt, these are the independent sources which are present. So these all are short circuited because they are voltage source, and this 4 ohm is already, from there we have to see. Okay, so it is open circuited and from there you have to observe Norton's equivalent resistance. So if you observe you will get that this 2 ohm and this equivalent, that is 4 ohms. Okay, these 4 ohms will come in parallel with each other, so you will get Rn will be equals to 2 parallel 4, which will give you 4 by 3. And the last step, fourth step, will be that we have to keep Norton's current in parallel with Norton's resistance, and that will be in parallel with load resistance which you had short circuited in the first step. So bring the load resistance over here, that is 4 ohms. So now you have to apply current divider. If you want to find this current through 4 ohms, what it will be, current divider rule says that it will be equals to total current, that is source current 6.5 ampere, multiplied by opposite branch resistance. So if you are finding for 4 ohms, opposite branch resistance will be 4 by 3. So see here 4 by 3 divided by this term. This term is nothing but addition of 4 by 3 plus 4. Okay. So it means that current divider rule. Okay. Current divider rule, you can say that it will be equals to total current or source current multiplied by opposite branch resistance. Okay. Opposite resistance divided by total resistance. Okay, total resistance. So this will give you current through the resistance which you want to find. So that comes out to be this value. I hope that you got the numerical. So let us go to another numerical and understand the Norton's theorem. So now you in this circuit, so this is a big circuit compared to previous one. So over here you have to find the current through 100 ohms. So 100 ohms is over here. So you need to find the current over here. So let us try to solve. So first step, so see first step will be you have to short circuit it. Okay. So this will be your first step. Wherever you need to find current, short circuit that element. So see if you see observe here, this circuit looks series parallel combination. So what I have done. So if you see from the back, you can see 100 voltage in series with 40 volts. Okay, so over here you can see. So this voltage source in series with resistance can be replaced by a current source in parallel with that resistance. So it will be 100 by 40, it will give you 2.5 ampere, and over here this 40 ohms comes in parallel. So now what will happen, this 40 ohms and this 20 ohms are in parallel. So you can find the equivalent of these two. So that comes out to be 800 by 60, and that will be with a current source. So again this current source and this resistance are in parallel. That will give you voltage source in series with resistance. Okay, so now this 800 by 60 and 20 are in parallel series. Okay, so you can find it further. So that those two when they come in series, that will be 33.3 and voltage is also 33.3. So this voltage source in series with this resistance is again converted to a current source and the resistance is brought in parallel. This current value I will be from V by R. Okay, it will be from V by R. So V is this voltage V and resistance is this. So 33.33 divided by 33.33 will give us 1 ampere. So 1 ampere comes in parallel with 33.33. Now you can see, if you see here, current is flowing downwards over here and over here current is flowing upwards. Okay, so it means that minus 2 ampere and plus 1 ampere. So it will be minus 1 ampere. Okay. Or if you take downwards direction as positive and upward direction as negative, then it will be downward direction 1 ampere. So 1 ampere downwards is in parallel with 33.33 and that will be in parallel with 20 ohms, and over here I have kept this much part as unchanged. So whatever term you need to find, that portion you should never touch it. Okay, this is my thumb rule. So over here this 10 volt and over here this is the Norton current which you need to find. Okay, this equivalent of 20 ohm and 33.33 will give you 12.5 ohms and you already have here 1 ampere. Okay, so you can further solve this. This current source is in parallel with the resistance. So you can solve the circuit using voltage source transformation. So this will come out to be 12.5 ohm and over here this will be 12.5 ohm in series with. So if you solve now, so you will get this by simply a KVL loop. So it will be 10 minus 12.5 ohms into IN and over here plus 12.58 volts. So that will give us IN to be 1.8 ampere. So I think that now you have understood how to solve the Norton's theorem. Okay. So this Norton's resistance we have found. So after this we have to find Norton's current. Okay, so to find Norton's current, what you need to do? So we have to find Norton's current over here. So Norton's current is found to be here. So you have to open circuit that much part and other all voltage sources are to be short circuited and current sources are to be open circuited. Okay, so over here you can see Norton's resistance is nothing but this 30 ohm and 10 ohm is in parallel with 20 ohm. So 40 ohm is in parallel with 20 ohm, and that will be in series with this 20 ohm. So this is plus 20, and this whole equivalent will be in parallel with this 20 ohm. So it will be over here. So you get equivalent to be 12.5 ohms. So now this Norton current and this 12.5 ohm resistance is in parallel, and this whole thing will be in parallel with this 100 ohms which was initially removed or short circuited. So now you can find this Norton current by current divider rule. So I hope that you have found the answer. Thank you.